Okay, so one way to monitor global warming is to measure the average temperature of the ocean. Researchers are doing this by measuring the time it takes sound pulses to travel underwater over long distances. At a depth of 1,000 meters where ocean temperatures hold steady near 4 degrees Celsius, the average speed is 1,480 meters per second. So, at 4 degrees Celsius, the velocity is 1,480 meters per second. It's known from laboratory measurements that the sound speed increases 4 meters per second for every 1 degree Celsius increase in temperature. So, the velocity changes 4 meters per second for every 1 degree Celsius increase. In one experiment where sounds generated near California are detected in the South Pacific, the sound waves travel 80 kilometers. So they travel 80 kilometers, which is equal to 8 times 10 to the 6 meters. And the smallest time change that can be reliably detected is 1 second. What is the smallest change in average temperature that can be measured? So we get that the change in time is 1 second, and we're asked to find how much the temperature changes. So to begin, I have this graph that's going to help us visualize how the speed of water underground works. We can tell that as the temperature increases, we're going to expect the speed to increase as well until we get to about 70 degrees Celsius, but that isn't relevant to this problem. So to begin solving this problem, we have to stop and think, how do we expect global warming, which we know that is increasing the temperature of the ocean, to affect the speed of sound underground? And from the graph, we can tell that the velocity is going to increase because as temperature increases, the speed increases. So let's begin by solving how long it takes the sound wave to travel 8 times 10 to the 6 meters at the speed that we're given. So we know that velocity is equal to distance over time, therefore time is equal to distance divided by velocity. And if we plug in our values, we're going to get that the time it takes is 5,405 seconds. Now, we are told that the time change that is detected is 1 second. We know from the intuition that we just gathered that that means that the time has to change by 1 second less because, like we said, the velocity is expected to increase, and from our equation we know that a smaller time is going to mean a bigger velocity. So to get the new time of how long it's going to take the wave to travel the 8,000 kilometers, we can subtract 1, the time changed by 1. So the new time is equal to the time that we just found minus the change in time, which is going to give us 5,404 seconds. So now we can calculate what the new velocity is going to be. So the new velocity is going to be equal to x, which is the amount it travels, which we're given as 8,000 kilometers, divided by the new time that we just solved for. So if we divide 8,000 by 5,404, we're going to get that the new velocity is equal to 1,480.3 meters per second, which is slightly larger than the velocity that we were given. So that is exactly what we expected. The velocity did increase. So now to find how much the velocity changed, we just simply subtract the velocity that we found from the velocity that we were given, and so we're going to get that the velocity changed by 0.3 meters per second. And the problem stated that the velocity increases 4 meters per second for every 1 degree Celsius. So we can write that out as that the change in velocity is going to be 4 meters per second per 1 degree for every 1 degree Celsius, and then multiply that by the time, and that is how we could get what the change in velocity is. But we already have what the change in velocity is. We just got that it is 0.3 meters per second. So with this equation that we derived, we can solve for change in time. So change in time is equal to 0.3 meters per second divided by 4 meters per second, and that is going to give us that the change in temperature was 0.075 degrees Celsius.